Hi, folks. Welcome back. We're at the end of page 1 here. We're about to jump into page 2, which is we will do on page 2. We'll do question 117. But I want to jump back to page 1 here real quick. The title of the lesson is Studying Quadrilaterals on a Coordinate Grid. And I know what you're thinking. We just did an entire long problem and there wasn't a single quadrilateral in it. There was just two line segments that intersected. We calculated their lengths. We calculated their slopes. We derived a formula for each segment, and then we determined where they intersect. Those skills are going to become important when we actually get to studying quadrilaterals on a coordinate grid, which is what we'll do in the next question. So question 7-117 says, am I special? Naturally, you'd ask this question. Certainly all quadrilaterals are special, but what we're talking about here are those that we look back on the org chart. So we're talking about things like parallelogram, kite, trapezoid, rhombus, rectangle, and square that have very special properties. Any four-sided polygon is a quadrilateral, but only those 1, 2, 3, 4, 5, 6 listed here have special properties. So that's what we're referring to. Okay, so back to question 7-117. Quadrilateral Shay, S-H-A-Y, is shown to the right. Find the length and slope of each side. So I'm going to go ahead, and we've already done this on the previous page. I'm going to try to rip through the four sides of this quadrilateral and those calculations pretty quickly. Let's start with segment SH. I hope you recall that division by 0 is an undefined operation. So the slope of segment SH, this guy right here, it's undefined. And that should make sense, because I also hope you remember that vertical lines have undefined slope. Okay, now let's take a look at the length of segment SH. Now this is easy enough to count on the graph paper, because any vertical or horizontal segment, we just count squares, and that's 5. Real quick other reminder here. Notice how here I have a symbol on top of the letters SH, but down here I do not. When you see the symbol above the letters, that is specifically referring to the segment itself. When the symbol is missing, that's referring to the length of the segment. Now I'm going to jump in and do the next segment. We'll go around this thing counterclockwise. That's going to be HA. Okay, so I have the slope of segment HA is 3/4, and the length of HA is exactly 5. Let's move on now to segment AY. I get a slope here of 4 divided by -3. I prefer, if it's okay with you, I like to keep my negative signs in the numerator. I just think it's a more standard way to do it. Just as long as you only have one negative sign in the fraction, then the entire fraction is negative. So let's now look at the length of segment AY. Okay, segment AY is 5 units long. That's the same as segment HA. We've got one more to do. Let's take a look at this last segment, which is YS. There you have it for segment YS. It has a slope of 4/7 and a length of 1.732, which is approximately the square root of 65. I want to zoom out a little bit here now, just so we can kind of take a look at all those different values that we calculated. We've got the length and the slope for all 4 sides. Let's make some comparisons here. We have segment SH, which is equal to 5 units. We also had HA, which was equal to 5 units. And last but not least, we had AY, which was also equal to 5 units. So all 3 of those segments have the same length. I'm going to mark that in the drawing. Anytime we have segments that are the same length, we can mark them as congruent. Now let's take a look at some of the slopes here. I see the slope of HA is 3/4, and the slope of AY is -4/3. Let's go ahead and take a quick look at these over here. If I take a slope of 3/4, and then I go through that little transformation we talked about, the opposite reciprocal, which means I change the sign and flip the fraction, we can see that segment HA and segment AY are actually perpendicular because their slopes are opposite reciprocals. So I'm going to add a right angle mark in the picture between HA and AY. Okay, so that's some things I noticed. Let's now jump down here to the next part of the problem. It says, based on your calculations above, does the quadrilateral have any special properties? Well, the first thing I notice is that it looks like it might be a trapezoid, but it's not. If it was a trapezoid, these two segments, HA and YS, would have to have the same slope. They do not. 3/4 and 4/7 is not equal. So I'm going to make a comment regarding that. So since no two sides have the same slope, there's no parallel lines, no parallel segments in this quadrilateral. Next thing I'll make is just the same things we already mentioned. We have 3 congruent sides, and I'll be very formal about this. I'll write it 2 different ways. We can say that segment SH is congruent to segment HA, which is congruent to segment AY. And the reason for that is because all 3 of those lengths are 5 units. Last but not least, let's make that comment about perpendicular, the 2 perpendicular segments. I can say that segment HA is perpendicular to segment AY because their slopes are opposite reciprocals. Okay, folks, last comment here is this is what we're asked to do oftentimes when we are analyzing quadrilaterals on a coordinate grid. We have to figure out if it's any one of the special quadrilaterals. What's required of you when you do that is you must calculate slopes, you must calculate lengths. That's the only way to analytically determine if segments are equal or if segments are parallel. So this one wasn't very interesting because it turned out to not be a special parallelogram, but please tune into the extra problem I do in this section 7.3.1 because that one might turn out to be a special quadrilateral.